Hello. This is our video for evaluating and simplifying rational exponents and radicals. Our essential question is, how do we simplify rational exponents and express radicals as rational exponents and vice versa? First thing we're going to do is review the properties of exponents. You have the product property, a to the m times a to the n equals a to the m plus n. And you can see the example over here. Power of a power, a to the m to the nth power equals a to the m times n. Power of a quotient, a divided by b all to the mth power is equal to a to the m over b to the m, provided that b is not equal to 0. Power of a product, the product of a times b raised to the m power is equal to a to the m, b to the m. And the quotient rule, a to the m divided by a to the n is equal to a to the m minus n, again provided that a is not equal to 0. And you can see some examples over here for each one of those properties. Go ahead and pause, copy these properties down, and we will get to some examples. Okay, first example, we want to evaluate each expression. We have problems A and B. And the first one, we have 2 to the 4th times 2 to the 8th divided by 2 to the 5th. We're going to do a combination of a couple of properties. We're going to do the product property and the quotient property. So the first one we're going to do is the product property. 2 to the 4th times 2 to the 8th. Using the product property, this is going to be 2 to the 4 plus 8, which is 2 to the 12th. Then we're dividing that by 2 to the 5th. The quotient property says that we now take our exponents, because we have a common base. We're going to take the exponents and subtract them. So that will become 2 to the 12, take away 5, which is 2 to the 7th, or 2 to the 7th is equal to 128. So this is our answer to problem A. Problem B, we have 2 divided by 5 to the negative 1 power. Anytime you have an exponent to a, or you have a base to a negative power, basically what that's going to equal is, it's called the reciprocal property. It's going to be 1 over whatever that base is to that power. So the negative exponent just means you make a reciprocal out of it. So the first thing I'm going to do is I'm going to take 2 to the 5th, and I'm going to make that into a reciprocal. So it's going to be 1 over 2 to the 5th. By doing that, that negative 1 power becomes a positive 1 power. And now I have 1 divided by 2/5, so it's going to be 1 divided by 2/5. Remember, we keep the first one the same, change it to multiplication, flip the second one. So 1 times 5 over 2 is equal to 5 over 2. So that is it for example B. The answer is 5/2. Next example, we're going to simplify some expressions this time. It's an expression because we've got variables in there, not just numbers. We've got s squared t cubed all to the 5th power. We're going to do a couple of different properties on this. We're going to do power of a product, and we're also going to do power of a power. Each one of these needs to get that 5th power. So this is going to be s to the 2nd raised to the 5th power. Remember, when we raise something to a power, we're going to multiply the powers. And then we're also going to do t to the 3rd, and that's to the 5th power. Again, we're multiplying our exponents. So 2 times 5 for the s is s to the 10th. And then the 3 times the 5 for the t becomes t to the 15th. So our final answer is s to the 10th, t to the 15th. And then example B, we have x cubed y divided by x to the 4th to the 3rd power. Again, this is a couple of different properties. We're going to do power of a power, and we're going to do a quotient property. First one I'm going to do is power to a power. So we got x cubed y over x to the 4th to the 3rd power is x to the 4 times 3, which is x to the 12th. Now we're going to do the quotient property. We have x cubed y divided by x to the 12th. I need to subtract my exponents, so I get x to the 3 minus 12 times y. You have to subtract the exponents of the ones that have the common base. And that becomes x to the negative 9 times y. Sometimes in calculus we leave it in this particular format, but most of the time we are going to go without the negative exponent. So to make that a positive exponent, we're going to move it to the denominator. So we end up with y on the top divided by x to the 9th on the bottom. And this is our final answer. Go ahead and pause, finish copying down these examples, and we will move on to some more examples. Okay, we have a definition of a base to the 1 over n power for any real number b greater than or equal to 0 and any integer n greater than 1. B to the 1 over n is going to be the nth root of b. This is also true when b is less than 0 and n is odd. So we want to evaluate each expression, and we have this example. We have 125 to the 1/3 power. First thing we're going to do is break down the 125 into its basic components. 125 is 5 to the 3rd power, and we want to raise that to the 1/3 power. Now we're going to do power to a power rule. So we have 5 to the 3rd times 1/3 in our powers. And when we take 3 to the 1, or 3 times 1/3, we get 1. So now we have 5 to the 1st, or just 5 as our answer. Now again, when you have a number like this, if you're not good at breaking it down, if you don't know that 125 is 5 cubed, you could do your factor tree to figure out what your factors are. And that's where I got the 5 to the 3rd power. Over here we have example B, square root of 14 times the square root of 7. I want to rewrite this as fractional exponent, so square root of 14 is the same as 14 to the 1/2 power. Again, the bottom number is whatever the root is that you're taking, since we're taking a square root. There's a 2 on the bottom. 7 is also, or square root of 7 is also 7 to the 1/2 power. Now that I have it written that way, I'm going to break down 14 into its components. 14 is 2 times 7, being raised to the 1/2 power. And then we still have our 7 to the 1/2 power. Now, using power of a product rule, I'm going to raise each one of those to the 1/2 power. So 2 to the 1/2 times 7 to the 1/2. And then we still have our times 7 to the 1/2 at the end. And now these two that have the common base can be combined together. So we have 2 to the 1/2 times 7 to the 1/2 times 7 to the 1/2. I'm going to add our exponents. This is our product property. 1/2 plus 1/2 is 1. So our power is 1, so we have 7 to the first power. And so now we can finish writing this answer. 7 to the first is just 7. We're going to put that number in front. It's going to be our coefficient. And 2 to the 1/2 is the same as the square root of 2. Go ahead and pause, finish copying these examples, and we'll move on to some where we simplify the expression. Alright, our next example, simplifying the expression. Example A, we have 81 c to the 4th raised to the 1/4 power. We're going to start off by breaking down the 81. 81 is 9 times 9. 9 is 3 times 3, and 3 times 3, so we have 3 to the 4th power times c to the 4th, and that's all raised to the 1/4 power. Now we're going to do our power of product rule. So we have 3 to the 4th raised to the 1/4, so 4 times 1/4 is going to be our exponent. C to the 4th raised to the 1/4 power, so 4 times 1/4 will be our exponent. And on both of these, 4 times a 4th is equal to 1, so we end up with 3 to the 1st times c to the 1st, or just c. Now this c to the 4th times the 1/4 power, we're going to need to take the absolute value of it, because we need to ensure that whatever this number is comes out positive, because of our rule up here at the top. When we're raising something to the 1/n, our b number needs to be greater than or equal to 0. So we're just going to put absolute values around it. Alright, example B. The 6th root of 9x cubed. First thing we're going to do is we are going to separate this into 2 pieces. We're going to call it the 6th root of 9 times the 6th root of x cubed. Now we're going to rewrite it as a fraction for our exponent. So we've got 9 to the 1/6 times x to the 3/6. Now let's break down the 9. 9 breaks down into 3 times 3. So this will be 3 squared to the 1/6 power. And if I simplify this, this is x to the 1/2. 3/6 reduces to 1/2. Now when I raise my power to a power, 2 times 1/6 will give me 3 to the 1/3. And again, we're multiplying that by x to the 1/2. So finally, I can finish writing these back in radical format. 3 to the 1/3 is the same as the cube root of 3 times x to the 1/2 is the same as the square root of x. Go ahead and pause and finish copying these 2 examples. Okay, now let's talk about rational exponents. For any non-zero number b and any integers m and n with n greater than 1 and m and n having no common factors, b to the m over n is equal to the nth root of b to the m, which is equal to the nth root of b raised to the m power, except where the nth root of b is not a real number. We're only going to be dealing with real numbers, so this will work out fine. Alright, first example. Example A, we have 625 to the 3/4 power. First thing we're going to do is break down the 625. 625 is 25 times 25, and 25 is 5 times 5. We end up with 625 being 5 to the 4th power, and then we're raising that to the 3/4 power. So we're going to take our power of product rule. 4 times 3/4 is equal to 3, so we end up with 5 to the 3rd power. Because remember, we take our exponents and we multiply them when we're raising a power to a power. And 4 times 3/4, the 4's cancel, we end up with 5 to the 3rd. Okay, second example. Example B, we have 16 to the 3/4 divided by 16 to the 1/4. We're going to use the quotient property, which says if we have the same bases, we can subtract our exponents. So 16 to the 3/4 divided by 16 to the 1/4 is equal to 16 to the 3/4 minus 1/4. Now we're going to take and subtract our exponents. 3/4 take away a 4th is the same as 16 to the 1/2 power. And 16 to the 1/2 is the square root of 16, which is equal to 4. Go ahead and pause and finish copying these two examples, and we will move on with some more examples. Okay, next example, example A. We want to express the cube root of 64 s to the 9th t to the 15th using rational exponents. So the first thing we're going to do is we're going to rewrite this entire quantity as 64 s to the 9th t to the 15th raised to the 1/3 power. Our root, remember, is our denominator on our rational exponent. And then we're going to use the power of product property. So this is equal to 64 to the 1/3 times s to the 9 times 1/3 times t to the 15th power times 1/3 power. Now we simplify our exponents. 64 to the 1/3 is the cube root of 64, which is equal to 4. S to the 9 to the 1/3 power, 9 times 1/3 gives us 3, so we end up with s to the 3rd power. And then t to the 15th to the 1/3, 15 times 1/3 gives us 5, so we end up with t to the 5th power. And that is our final answer. Example B, we want to express 12x to the 2/3 times y to the 1/2 using a radical this time. So we're going backwards. So the first thing we're going to do is we're going to take our x and our y, and we're going to come up with a power that they are both, that we can divide out of both of them to get our exponent. So a common exponent between 2/3 and 1/2 would be 1/6. So that's going to be our common power. 2/3 in terms of 1/6, or in terms of 6th, would be 4/6. This would be x to the 4th. And then 1/2 would be 3/6, so on the inside we would have y to the 3rd. If you multiply this out, we get x to the 4/6, which is the same as 2/3, y to the 3rd, times 1/6 would be y to the 3/6, which is the same as y to the 1/2. And now we're going to take and finish writing this as our radical. So we end up with 12 as our coefficient. It's the 6th root, that's what 1/6 stands for. So the 6th root of x to the 4th, y to the 3rd. Go ahead and pause and finish copying this example. Last example, sorry for the pause, I forgot to pause it. We want to simplify the square root of r to the 7th, 5 to the, or s to the 25th, t to the 3rd power. And first thing we're going to do is rewrite this as a rational exponent. So this would be r to the 7 over 2. Remember that this is a square root, so there would be an index of 2 right here, which is my denominator. So r to the 7 over 2, s to the 25 over 2, t to the 3 over 2. Now that I've done that, I can rewrite this as r to the 7th, s to the, no, that wouldn't help, so don't do that. So I have r to the 7 halves, s to the 25 over 2, and t to the 3 halves. Now, when you are trying to simplify this, what you want to do is you want to take your numerator, we divide by the denominator, we see how many times it will go in there. 2 goes into 7 3 times with a remainder of 1. So however many times it goes in there is how many whole exponents you have, and then the remainder would still have to be rewritten as a fraction. So I can rewrite r to the 7 halves as r to the 3rd times r to the 1/2. I want to do that so that I can take out my whole number exponents. They can come outside the radical. So that's my goal. S to the 25 over 2, 2 goes into 25 12 times with a remainder of 1. So you can break this down into s to the 12th times s to the 1/2, and t to the 3 over 2 breaks down into t to the 1st times t to the 1/2. Now all of these that I am taking out, we're going to be taking out the whole number exponents. So r to the 3rd comes out in front, s to the 12th comes out in front, and t comes out in front, and then the ones that are rational exponents go back inside. Remember, 2 is our denominator, so it's our index. We're taking the square root. So I end up with r to the first underneath times s to the first times t to the first. Now the r and the t, because they are being raised to an odd power, they need to be positive, and I don't know whether they're positive or not. S to the 12th is going to come out positive anyway, because when you raise a number to the 12th power, it will always come out positive. So the r and the t need to be positive. I don't know if they are or not, so we're going to have to take and put them into absolute values. So we end up with the absolute value of r to the third power, s to the 12th, times the absolute value of t, times the square root of r s t. This was our final example. So go ahead and pause and finish copying your notes, and we will see you in class.